Kids, it's Mr. Agee here to talk with you about your math assignment and the mini lesson for Wednesday, November 11th. We've had we've had some a few days here, or a couple of days, where I haven't been able to have live lessons with you. Over these last 2 days, we really focused on adding with regrouping, or carrying, as you might call it, using the standard algorithm. We also practiced mental addition with larger numbers, and we also talked about using estimations to compare to actual sums. So estimating the sum by rounding and actually finding the sum by doing the computations with the exact numbers. We're going to switch gears today, and the focus is on subtraction. And so as we go through, you'll see that the lesson focus is to subtract many times. It's basically a practice lesson. It's a review lesson of subtracting, specifically subtraction in the standard or using the standard algorithm with regrouping. Your parents probably learned this as borrowing. You may have heard it last year as borrowing. I learned it as a child as borrowing. We call it regrouping now as teachers because we regroup tens as ones or hundreds as tens, and it's a kind of a fancier way to talk about it, a more accurate way of talking about it. Somebody in my class brought it up that when we borrow, we're not actually paying it back. So is borrowing really a good term for it? And I thought that was a pretty good point. But anyway, to get to the assignment in your workbooks, you can follow along here. I'm going to click into the math folder and for Wednesday, and I'm just going to do a couple of these and then save the work for tomorrow because I actually will get a chance to work with you live tomorrow. Well, I'm doing this lesson on Tuesday so that it's ready for you on Wednesday, so you have something to look at and go back to as you do this assignment on your own. So you can, if you don't have your workbook, you can open up the assignment with Kami. It's the lesson 18 problem set. I've already loaded in a little bit of work so that I didn't waste my time putting the numbers in and everything. Just like in adding, when you set up the standard algorithm for subtracting, it is vitally important, critically important, absolutely fundamental that you line up the ones with the ones, the tens with the tens, and the hundreds with the hundreds, and so on. As you get into bigger and bigger numbers, keeping the place values lined up together is the number one most important thing, because when you're adding and subtracting using the standard algorithm, you work ones with ones, tens with tens, hundreds with hundreds, and so on. So you can see I've stacked the numbers so that the ones are on top of the ones, the tens are on top of the tens, and the hundreds are on top of the hundreds. All I've done is just rewritten these expressions in the form of the standard algorithm. So the standard algorithm is just the larger number on top of the bottom number. Now, when we were doing addition and multiplication, we talked about the commutative property and how the order of the parts of the problem doesn't really make a difference. You can add if you have 2 add-ins or 3 add-ins or 4 add-ins, if you put them in any order, you end up with the same sum. And it goes the same for multiplication because of the commutative property. You can put those factors in any order. But when you're subtracting, or if you're dividing, the order is important. You cannot reverse them. You're not going to put the 24 on top. You're going to keep the 60, the first number, on as the top number, and the second number has to be the bottom number, okay? Because the order is another thing that's very important in subtraction. So I'm looking at this right here, and I see that I start in the ones place. Well, first I can do a mental estimation. I can say, okay, 60 minus about 20 should get me around 40. And then if I take 4 more away from 40, I end up with 36. So mentally, I just perform the calculation. But you need to know how to do this by hand as well, because sometimes the numbers are just so big, doing it mentally is just not really an option. So you have to have strategies, written strategies for this. So we've got 0 ones, and I'm trying to take away 4. So obviously I need more ones. Now it appears as if I have none, but I actually have 60 ones here. So if I go over here to these 6 tens and I say, okay, I'm gonna say these tens, I've got 6 of them. I'm gonna take one of those tens and I'm gonna regroup it as 10 ones. And since I have no other ones here, I'm just going to stick the 10 up here because I've got 1 10 that I'm turning into 10 ones. And that means that I'm going to have 5 10s left. So now I've got 5 10s and 10 ones, which still adds up to 60. Okay, and that's what I'm starting with here. So now I have enough ones to actually do the calculations. 10 minus 4 equals 6. And now I can just do my move over to the tens place, and I can do 5 minus 2. 5 minus 2, the difference between 5 and 2 is 3. So 36. So my mental calculation was accurate, and performing this borrowing method was also accurate. So here we've got a similar number here, 360 minus 24. So if 60 minus 24 was 36, then 360 minus 24 probably still ends in 36, but I've got to remember that I've got 300 more here that I'm starting with. So the final difference is going to be 336. But let's just prove it. I have 0 ones trying to take away 4. I don't have enough, so I'm going to go over to the 6 tens, and I'm going to make one of those 6 tens 10 ones, like this. Yep. And now I've got 5 tens left. And so 10 minus 4 is going to give me 6. And then 5 minus 2 gives me 3, just like in before. And it's important that I try to keep these organized and lined up, neat, and just very clear. The more, if you smash the numbers together or you do things in kind of a disorganized way, you're going to end up making calculation mistakes. So now I've got 3 hundreds minus 0 hundreds. So 3 minus nothing, or 3 minus 0 is 3, 336. Okay, so now I have a related problem, 360 minus 224. So I did 60 minus 24, 360 minus 24, and now I'm sticking 200 more into the number I'm taking away. So it's the same basic thing. I'm going to end up with 36 in 3 in the tens place and 6 in the ones place, and now 3 minus 2 is going to give me 1. So I should end up with 136, but I have to do the same process. 0 tens, or I'm sorry, 0 ones minus 4 ones. I can't do that in this algorithm. Now, technically you can do 0 minus 4. You just can't do it in this algorithm. 0 minus 4 would end up being negative 4. But negatives, it wouldn't make sense to have a negative 4 down here in my difference. This algorithm is built to work with positive numbers. So 0 minus 4, can't do that. So I'm going to come over here and I'm going to unwrap one of those 10s and turn it into 10 single units, 10 ones. 10 minus 4 is still 6. It's 6 over and over and over again. I've got 5 10s left because I unwrapped one of those 10s and turned it into 10 ones. 5 minus 2 is 3. And then 3 minus 2 is 1. This is good for fact practice, for subtraction. If you're having to count on your fingers, that's okay. It's okay, because the good thing for you is when you use the standard algorithm, the biggest number you're ever going to be dealing with over here is 9. And so you will be able to use your fingers to count to the number. Now, if you use it, I just know my facts, and when I taught second grade, I wanted to make sure that all my students knew their addition and subtraction facts. If you don't know your addition and subtraction facts, it's a good idea to practice those. If you're having to count and you're struggling with it, here's a strategy. So I'll start with the lower number and count up to the higher number and keep track of how many numbers I go up by raising a finger for each one. So I'll go start at 4, raise a finger for 5, 6, 7, 8, 9, 10. I've got 6 fingers up. You can't see it, but it's true. So I can see that the difference between 4 and 10 is 6. That's a strategy that will work every single time. Okay, now moving down, I'm going to do these with you tomorrow in our lesson because borrowing across zeros is a pretty tricky skill. And so I want to make sure I go over these with you tomorrow. And down at the bottom here, we've got mixed measurements. So you've got kilometers and meters in the same measurement, 2 kilometers and 770 meters minus 1 kilometer and 455 meters. As long as you keep them separate, you're going to be fine. You subtract the meters first, label the meters, subtract the kilometers second, label the kilometers, and as long as you are keeping those measurements separate, then you're going to be just fine. Now, in the future, you'll learn how to convert kilometers and meters to just meters, or a certain number of meters to kilometers. But for now, we're just practicing using the standard algorithm to add and subtract, and then we'll move forward from there. The second part of the assignment here is going to ask you to do word problems that involve subtraction. So we are still practicing subtraction here. And so what it's helping you to identify is words that help you kind of key in to the fact that it's a subtraction problem. You know, one of the big tricks in third grade is to figure out, when you read a word problem, what kind of operation do I do? Do I add, subtract, multiply, or divide? So you're getting some repetitions here with problems that ask you to subtract. So knowing that ahead of time, think to yourself, now if I saw this in a mixed practice worksheet where the problem doesn't, so when I don't know if I'm subtracting, how do I decide to subtract? Okay, so the total weight of 3 books is shown to the right. All right, so it gives the total weight of 3 books. See the 3 books, 1, 2, 3. The total weight is 405 grams. If 2 books weigh 233 grams, how much does the third book weigh? Okay, use a tape diagram to model the problem. All right, so we've got the total is going to be, I'll show you the tape diagram model using this here. And so I'm going to use one long tape to represent the total of 3 books, and I'm going to label it with the text box. I'm going to label it with the total of 3 books, which is 405 grams. Now I'm going to build a second tape here that represents 2 of those books, okay? That represents 2 of the books. So I'm going to line up the left-hand edge here to show that 2 of those books are 233 grams. It's a little bit more than halfway, so I'll probably go back about this way here. And now I'll build this tape to say 233. So with the tape diagram, what we're looking for is the difference. When you build a tape diagram for subtraction, it's usually 2 pieces of tape. One piece of tape shows the first number that you're going to be using to take away from. So, and then the second tape is going to be a little bit shorter, and it shows what you are taking away. So I'm taking away 233 from 405, or I'm looking for the difference between these two things. In fact, the answer to a subtraction problem is called the difference. And when we model it with a tape diagram, it looks kind of like this. We look for the difference. So from one end of the tape, of this smaller tape here, to, I'm just going to kind of roughly line it up with the end of this bigger tape here, to here. Oh man. Thought I had it right, and then at the last second I lifted it up. So the big idea here is, what is this distance? What is the distance from 233 to 405? So I would put question marks here to show that this is what I'm looking for. Now, if I were to set it up in a problem in the standard algorithm, I would go 405, 4 space 0 space 5, and then a minus down below, and I would be subtracting 233 from that. Now, when you set these problems up, you want to make sure that you give yourself space on top of the problem to do the borrowing work that you know you're going to be practicing. So wherever you set up this problem, just make sure you've got some space up here to do that borrowing work. And you can see right here, you don't really need to borrow in the ones. You've got 5 in the ones, and you're taking away 3. So that's 2. And then 0, okay, 0, take away 3. No, we're not going to be able to do that without getting negative. So I'm going to unwrap one of these hundreds. I've got 3 hundreds left, and one of those hundreds is going to be 10 tens. So I'm going to put that 10 right above here and cross this 0 out. And this 10, now I have 10 tens to take away 3 tens. That gives me 7. And 3 hundreds minus 2 hundreds is 1. So the difference here between 405 and 233 is going to be 172 grams. That tells me the weight of the third book. So it's just putting together some reasoning, some modeling, some calculating to try to solve the problem. All right, I'm down to my last 10 seconds here. I'll see you in the morning. By the time you see this, I will have already seen you most likely, and you can continue your work completing the problem set and the homework. Good luck. Can't wait to see you.